All right. Find the exact value of cosine if the sine is 6/11. Okay. We should be able to do this. If we're in quadrant 1, we just draw a quadrant 1, and we just draw a random old triangle in quadrant 1. Now, we're told the sine is 6/11. What two sides of the triangle do we know if we're told the sine is 6/11? The opposite and the hypotenuse is 6/11. What do we need to find the cosine? The adjacent. How can I find the adjacent side of a right triangle? Pythagorean theorem. 11 squared equals 6 squared plus a squared. 121 equals 36 plus a squared. Subtract 36 from each side. A squared equals 85. Take the square root. Any perfect squares go into 85. I don't think so. So I think it's the square root of 85. So what's the exact answer? Well, it's the square root of 85, the adjacent side, over 11, the hypotenuse. Okay, let's do that again for a little different one. Find the sine of A if the sine is going to be negative and the cosine is positive. Well, what quadrant would I be in if the sine is negative and the cosine is positive? Quadrants 1, 2, 3, or 4. Let's think a little bit. Which quadrant would I be in? 1, 2, 3, or 4. Cosine is positive. So where on your unit circle are your x values positive and your y values negative? Which quadrant? 4. So I'm down here somewhere. So draw my triangle down here. Cosine is my adjacent side over my hypotenuse. Now I have to find the opposite side. So again, use Pythagorean theorem. 3 squared equals 1 squared plus b squared. 9 equals 1 plus b squared. 8 equals b squared. Take the square root. Any perfect squares that go into 8? 4 does. So it's the square root of 4, square root of 2, or 2 square root of 2. And it's a negative 2 square root of 2 because I'm going down below the x-axis. So what is the sign there? Well, it's negative 2 square root of 2 over 3. That's the exact answer using radicals. Okay? So, got to be able to use the Pythagorean theorem. Got to know what quadrant what is in. So, you cannot write this on your unit circle, but in the first quadrant, cosine's positive, sine's positive, and tangent is positive. If you want to write it in your notebook, that's fine, but you cannot write it on your unit circle. In the second, and then their cofunctions are the same sign. So secant's the same as cosine, cosecant's the same as sine, and cotangent's the same as tangent. So positive, positive, positive. Second quadrant, cosine, since we go to the left, is negative. Sine, since we go up, is positive. Tangent, since it's sine over cosine or y over x, it's a positive over a negative, which is a negative. Third quadrant, cosine, since we go to the left, is negative. Sine, since we go down, is negative. Tangent, since it's a negative divided by a negative, is a positive. In the fourth quadrant, cosine is positive, sine is negative, tangent is negative. So those are things that you need to know when we're in each quadrant, what the sign is, positive or negative. Make sure you know that. All right. Which one of these would be the graph of 330 degrees? A, B, or C? C would be, because we go around this far to get 330 degrees. What we'll talk about today is a reference angle. How far is it away from the x-axis? We never talk about reference angles in terms of the y-axis. It's always the x-axis. So how far is 330 degrees away from the x-axis? 30 degrees. In radians, what is 30 degrees? Well, you can look at your unit circle, look at 30 degrees, and see that it is pi over 6. That's its reference angle, is pi over 6. So, a 330 degree angle will use the same numbers as a 30 degree angle. It just, some of them are positive or negative. Okay? So if you only remember 30 degree angles, 45 degree angles, and 60 degree angles, okay, you know that 120 or 135 or 150 and so on are all developed from these angles. You just have to make a positive or negative sign. But with the unit circle, it's pretty easy just to look at that. So pi over 4, okay? Which one of these is pi over 4? And the answer is none of them. Okay, because there's probably a choice D that looks like that. Okay? So, what's a radian angle for pi over 4? That's its reference angle. Well, since it's in quadrant 1, it's going to be pi over 4. It's the same thing. Okay? Any angle in quadrant 1 is a reference angle, basically. So the reference angle in degrees for pi over 4 is how many degrees? 45 degrees. 615 degrees. That's nowhere on your unit circle. So before we can find a reference angle, I need to find a coterminal angle. How do I find a coterminal angle? Subtract 360 degrees. If I subtract 360 degrees, I get 200 and what? 55 degrees. Okay? 255 degrees. Where is that? Well, I think that's like right here. Okay? So, how many degrees away am I from the x-axis at 255 degrees? How far am I away from the x-axis? And it would be 75 degrees. What is that angle in radians? Well, 75 degrees, if we want to change it to radians, we multiply by pi and divide by 180. What's 75 over 180 as a reduced fraction? 75 over 180 as a reduced fraction, something over 12. 5 twelfths. So it'd be 5 pi over 12 if is its reference angle. 5 pi over 12. Negative 3 pi over 4. And again, ooh, is that angle on there? It is on here. Which angle is it? Negative 3 pi over 4. C. Okay. How far is it away from the x-axis? How far is that angle away from the x-axis? How many degrees is it away from the x-axis? 45 degrees. Okay. It's 45 degrees down from the x-axis. So the reference angle in radians would be pi over 4. Okay. Now, it says use reference angles to find these. The cosine of 330 is the same as the cosine of 30. Cosine of 30 is pi over 6. Okay. Sine of 4 pi over 3. 4 pi over 3 is down here somewhere. Okay. It's actually a little further down. It's more down here. Okay? That's the same as up here. Okay? Pi over 3. Well, the sine of pi over 3, whoa, did I say pi over 6? Oh, Mr. Bierschbach, it's square root of 3 over 2. That's what I meant to say. The sine of 4 pi over 3 is square root of 3 over 2. But since we're in the third quadrant, we're negative. We're negative. The sine of 4 pi over 3, that's the last problem. The sine of negative 8 pi over 3. All right. When I hit this, I need a coterminal angle to help me figure this out. Okay? What am I going to add to it to make it back to positive again? 2 pi. 2 pi is how many pi over 3? 6 pi over 3. So negative 8 pi over 3 plus 6 pi over 3 equals negative 2 pi over 3. Okay, but that's a negative. I want a positive, so I'm going to add another 6 pi over 3 to it, and it's going to be 4 pi over 3. And hey, it's the same as the last two problems. Square root of 3 over 2, and it's a negative, because the sine of 4 pi over 3 is negative square root of 3 over 2. Cosine of negative 15 pi over 4, coterminal angle. If we add 2 pi to it, how many pi over 4 am I adding to it? What over 4 is 2 pi? What am I going to add to this to be 2 pi? What over 4 is 2? 8 over 4 is 2. So I'm going to add 8 pi over 4. If we add these together, I get negative 7 pi over 4. If I add these two together, I get pi over 4. Cosine of pi over 4 is square root of 2 over 2. Okay? So, we can keep doing those. Exact values of the sine of 3 pi over 4, cosine of 3 pi over 4, tangent of 3 pi over 4, cosecant, secant, and cotangent. Well, sine of 3 pi over 4 is over here, which is the same as the sine of pi over 4. It's square root of 2 over 2. And since I'm in the second quadrant, it's going to be positive. Cosine of 3 pi over 4 is the same as the cosine of pi over 4, except for in the second quadrant, I'm negative. When these two are on top of each other, square root of 2 over 2 and negative square root of 2 over 2, I'm going to get a negative 1. Now, if we flip upside down, square root of 2 over 2 is 2 over square root of 2. Can't leave square root of 2 on the bottom, so I multiply top and bottom by square root of 2. I get 2 square root of 2 over 2, and the 2's cancel to be just square root of 2. If I flip this upside down, it's negative square root of 2. Flip this upside down, it's still negative 1. Okay? So you'll have some problems like that, sine, cosine, tangent, cotangent, cosecant, and so on. And finally, is the cosine of 150 the same as negative cosine of 30? Well, the cosine of 150 is negative square root of 3 over 2. The cosine of 30 is square root of 3 over 2. But if they say, what's the negative of that? It's negative square root of 3 over 2. They are equal, so it is true. The sine of 167 and the sine of 13. Don't know either of those right off the top of my head. Okay? But they're the same reference angle. Because 167, whoa. Get back here. 167 is there, 13 is there. 13 is 13 above 0. 167 is 13 above that. Okay? So they're the same reference angle, so they'll be the same amount, but are they opposite signs or are they the same sign? They should be the same sign, so this is a false statement because this says, well, they're opposites of each other, which they are not. Okay? Sine of pi over 24 and 23 pi over 24. Pi over 24, I think, is somewhere over there. 23 pi over 24 should be somewhere over there. Should they be the same sign or opposite sign? Same. Sign in quadrants 1 or 2 are both positive. This says they're opposite, so that's a false statement. Okay? Those are reference angles. If I'm 1 pi over 24 above the x-axis, then 23 pi over 24 will be 1 pi over 24 above the x-axis. Okay? So you'll have 20 problems to do today. So, here's what we got. This is the last section of the chapter. So, I would like to have a test on Friday. If you say, well, Mr. Shaw says we can't have a test on Friday, then fine. We'll have it next time on Wednesday. So what would you rather have? A test next time on Wednesday or a test on Friday? Friday? Everybody's comfortable with Friday? 45 minutes. So next time we'll review and we'll have a practice test for you to practice with it. And then Friday, come in. We're not going to review. You're just going to sit down and take it. We good? Good. Then that's what we'll do. Your assignment is out there. You can get started.